But if I were to do this and make a fist while the liquid is in my hand, the expanding gases would give me third-degree burns very, very quickly. So it is not to be toyed with, even though technically I'm toying with it. Anyway, can we get our video back? Our video is still dead. I hate that. All right, so I have to film. It doesn't matter. There was only great pictures there. I have here a styrofoam cooler, and I'm going to pour in, I'm going to figure, let's go 2 liters. I'm going to go 2 liters of liquid nitrogen. This is not, by the way, the vapor you're seeing is not nitrogen, okay? It is fog, okay? Because the liquid is so cold, the air around it, watch. The air around it gives up its moisture in the form of fog. So I've got, actually that doesn't feel like 2 liters. Let's go a little bit more. There we go. Now, I got April some flowers, because I think April needed flowers because she's suffering pretty badly tonight. Well, she's going to be soon, doesn't it? And I got these because I wanted to show you that nitrogen can actually freeze things so quickly that they become almost like another substance. See, when ice forms in irregular substances, water, the molecules line up. But they don't necessarily do that when liquid nitrogen is concerned. So I'm just going to drop these down into the liquid nitrogen. Oh, April, you're back. You look great. April, hi. How are you? You got your protective vest on. That's good. All right, come on in. You look like a demented dentist, which is kind of disturbing. So we've got that. We've got your fireman boots on to protect you. The most important thing: the cryogenic gloves and your eyewear, which has got something.
Spots all over.
Yeah, you got spots all over it. Don't worry about that. That's going to protect your eyes. Come on over. When is the last time you got flowers, April?
A week and a half ago, actually, I was in a play.
You were in a play. What were you in the play?
We did 9 to 5, the musical, and I played Dolly Parton's role.
You did?
I did. So I'm very familiar with the cowboy ballad song.
Yes. I wasn't going to say that, but I get it now that you say it. So you've gotten flowers, so these won't be that special for you. So these are for me, so they are a little more special. And they're steaming, which is extra important. Do me a favor, though, as part of this scientific demonstration for these folks, and unfortunately our video's dead, so we're going to have to make this really big. Okay. Give that a big thwack against the table. Okay. Let's just,
sorry.
I'm going to take those back. No, it's good. It's good. Sorry about that. That was as if you were mortified enough already by what your mom said. So obviously what happens is that when liquid nitrogen freezes things, it becomes more like glass. It actually becomes polymorphous, as we call it, which is going to actually save your cocktail in more ways than one. So I'm just gonna get this out of here. Guys, can you flip this table over for me? So here's the deal. This is a standard restaurant table. Have you ever worked in a restaurant, April?
I have.
What did you do in the restaurant? Front of house or back of house?
Front.
Front of house?
Yep.
That's where the money is.
Yep.
I think that. So I've got a bunch of these tables in my place in Atlanta, my warehouse, and we were moving things around, and I know that you guys can't see this, but there are metal trays on the bottom of a lot of these tables. They're stainless steel on one side, and then the underside has got aluminum. And I'm like, why? Why would you put aluminum on stainless steel tables? So I called up the manufacturer, and they're like, well, stainless steel, if you take like a really big pot of a hot liquid, like a stock, and you put it down on it, it'll warp it. It'll literally twist the table because of the thermal expansion. So what they do is they put another metal on the bottom, and in this case, it's 2 structures made out of aluminum, which conducts heat very quickly, unlike stainless steel. So this keeps the table from twisting. Well, I'm looking at this, and I'm like, well, why can't I make a cocktail into a snow cone on that? Because that sounds like a good idea, right?
Yes.
There are a lot of reasons for wanting to make a cocktail into a snow cone, and let me tell you what they are. The main thing is that by turning a cocktail into a snow cone, we can suppress the aromatic compounds. Can I get some more liquid nitrogen? Thanks very much. Todd's going to bring out some liquid nitrogen, just a little bit more. I'll take that one. You get the other one. I think we're going to need even more. Oh, we want to suppress the aromatic compounds. We want to change the texture, which your texture is better. We want to change the color. We basically want to change everything. So here's the deal. Here's what I want to do. I want to bring the temperature of this table down to 300 degrees below zero. Because the aluminum is such a good conductor, it is literally going to pull all the heat out of this table. Don't worry, that happens. It's okay. And then what we're going to do is we're going to add your cocktail. Now, have you ever seen anybody use liquid nitrogen on food before?
I have.
Like making ice cream,
yes.
Right? Like you mix it in and you spin it around and stuff happens. Well, that's not what we're going to do. We're actually going to create ice crystals, not on the liquid nitrogen, but on the very, very cold metal. So there is your version of the cocktail. which, by the way, I can smell from over here, and it is hideous. And it's a real shame that you're going to have to drink that later on for science. But that's just the way it's going to go. That's the way it's going to go. So here's the deal. As the liquid nitrogen boils away, the table is getting colder and colder and colder. The heat is being sucked out, literally boiling away on this liquid. So what I want us to do is we're going to use these yard sprayers to simply spray your cocktail. Just pull the trigger, spray it right on top of that nitrogen as that nitrogen boils away. And you'll see immediately, oh, we got our video back. Yay, video! We can see that they're actually, this is something that we're not used to seeing, is ice crystals forming on top of boiling liquid. Now when you make liquid nitrogen ice cream, you want to stir it because you're actually trying to use the nitrogen as an ingredient. We're not. All we want is very, very cold. Now you notice the color of your cocktail is changing. It's not quite as revolting as it was before. Less brown and more kind of orangey. Well, you're saying you can smell it?
I can see by the
I'm sure your chemical guy can explain why that's so bad. Just keep. Now you're doing. It's funny. You're kind of more of a direct, more gentle, using a little more finesse. You're being a little more direct with it, and it's forming a very, very different kind of substance over on your side than my side. There. I think that's probably enough. Let's just stop there. Now you can smell it, right? Because we've been spraying it, and it's. Oh my God, that's so bad. I don't know if it's the soy sauce or the tequila, or I don't know, maybe the Amaro. It's really, really bad. So look what we have here, and everybody can see this. We have got, mine is almost a powder, but it looks different. Okay, so we've turned it into an ice. Yours is a little more kind of like pudding pop, and mine's just a little bit more like ice crystal. So what we're going to do is we're going to scrape this up here. This is a sheetrock knife. Down south, we use these to smooth the joints between sheetrock. Here, you use it to scrape ice off of windshields, basically. We don't have a lot of that. When that happens where I live, it's called the apocalypse. And we run to the store. We run to the store and we buy all the bread and milk and wait for the end. Because we don't know how to use these. We just sell the car, because we can't see out of it anymore. That's the way it goes. They're not here. So here's what I want you to do. I want you to just start scraping and scrape all the way to the end. Now remember, this table is about 320 degrees below zero now. And yours looks already very, very different from mine. Mine's kind of fine and crystalline, like brown sugar, and yours looks kind of like...
Dippin' Dot.
Is it Dippin' Dot looking? It is kind of Dippin' Dot looking. That's okay. But don't let that fly off in the audience. You'll put somebody's eye out. Kind of like a stick of rosemary. There we go. Keep scraping all the way to the end. Keep going, keep going. Now that we're here, just scrape that out. There you go. Now, that looks like pudding. Almost looks like hummus. You like hummus? Because that kind of looks like hummus. Do you smell anything now?
No.
No, because it is so cold, the aromatic compounds in this cocktail have been repressed. Does it look, well, here, let's just give it a go. Here, let me take this one. Oops. Oh.
Okay.
Can you make another one?
I sure can.
Yeah, sure you can. All right, look. Does this look, to your eyes, April, more appealing than the cocktail before? Because it kind of looks like ice cream now, doesn't it?
Yes.
And everybody loves
Ice cream.
ice cream. So already, this cocktail is different for you, is it not?
Yes.
Okay, I'm gonna put this little, my powder on there, kind of like sprinkles. Just leave your knife. Come over here now. So looking at this now, would your eyes say, that might be okay, April, I might eat that?
Except for the smoke, sure.
It's not smoke, it's fog.
Sorry, fog, except for the fog.
All right, we'll get rid of that. All right, here, hold this. Todd, let's get a little heat on there. I'm gonna get this off. We'll put a little heat on there so that doesn't happen anymore. I'll get my thermometer, get my instant read thermometer here. We'll just warm it up a little bit for
There
you.
we go.
Oh no, that's still like minus 15. Hit it a little more. Okay, now that looks like creme brulee.
It does.
It does.
It does.
So, April,
Yes.
lick my science.
Well, that's one I haven't heard before.
Whoa, wait. What? What did you say?
I said that's one I haven't heard before.
You haven't heard anybody say that, but you've heard people say other things. Okay, fine. Just give it a little lick. Just a little lick. Go ahead. A little lick. How's it taste?
Here, you taste it. Are you scared?
I didn't spin the wheel. You did.
But you helped me make it.
She stood in her chair.
I stood in my chair.
I didn't stand in my chair. You stood in your chair.
You picked
wanted
me.
You wanted it.
Bicket.
It's not bad. Wait, that just needs. Wait, I know what that needs. Sprinkles. Science. But experiments are a lot about compare and contrast. Now that you've had the cold version, it's time to have the regular version that you spun for. To compare science and sprinkles. I think it's more the sprinkles with the soy sauce that's really doing it. All right, so April. You drank like 2 molecules. How do you even know what it tasted like? You got to at least take a sip for science. Is this one better or is this one better?
I dare you to try that.
Which one's better?
I double dare you to try that.
What? The double dog dare has been brought into play.
If you make me pull out the triple, I will.
Oh. Science! April, thanks for playing Spin Your Poison! Oh, that was horrible. Ladies and gentlemen, we're going to clean up. We're going to take a quick break. Watch this video. Come here, you.
Hello, Alton Brown here. I want to talk to you for just a minute.